If you follow the news, you've probably seen reports like this one, saying that our planet is in the midst of a terrible crisis, a mass extinction. Extinction is the end of a species. For one reason or another, all of the individuals of a species die off, and no living members remain to continue its legacy. Over the past few centuries, scholars have observed that many species have gone extinct. And problematically, they now believe that species are disappearing faster than they have at any other point in human history. This graph illustrates the number of extinctions that have occurred in the 16th, 17th, 18th, 19th, and 20th centuries. The vertical axis is essentially the number of extinctions. As you can see, more species of mammals, birds, and other vertebrates have disappeared over the last 200 years than over the prior 3 centuries. Indeed, while there is some debate about the exact number, some studies suggest that more than 400 species of vertebrate animals have gone extinct over the last 100 years or so. That's more than twice as many than the previous 400 years combined. Since 1990, there has been a startling uptick in the extinction of virtually all animals with backbones. The numbers of amphibian and fish species have been hit particularly hard since 1900. A surprising number have disappeared. Populations of animals have been shrinking and disappearing as well. Scholars have observed that many populations of vertebrate animals have vanished over the past few decades. Since 1970, populations of freshwater animals have declined in abundance by 81%. Terrestrial and marine populations have declined in abundance by nearly a third over that time. Currently, 41% of amphibian species are threatened with extinction, along with 25% of mammals and 13% of birds. Other groups of organisms face the same threat. It is clear then that the disappearance of species is a very real and very concerning trend. All of the evidence suggests that life on Earth now faces an unprecedented crisis, one that is unparalleled in human history. This crisis is probably a consequence of multiple causes. But any way you look at it, humans must be part of the problem. We produce garbage, waste, litter, and pollution that are harmful not just to ourselves, but also to the other forms of life that share our planet. We cut down forests, develop coastlines, bury wetlands, and destroy habitats that provide homes to countless other species. We play a key role in spreading invasive species and other pests, which wreak havoc on native populations around the world. And of course, we produce an astounding amount of greenhouse gas that has the power to cause climate change and fundamentally alter all ecosystems on Earth. Humans may very well be the cause of this mass extinction. This crisis is being called the sixth mass extinction because there have been 5 similar events in the history of life on Earth. But what were the mass extinctions? How do we know about them? What caused them? And what can they tell us about the current biodiversity crisis that we are facing? Species originate on our planet through a process called speciation. Populations of organisms evolve new traits and diverge from their ancestors over time, becoming increasingly different and unique. Extinction is the flip side of the coin. As we have observed over the past 500 years, species disappear all the time. It's important to recognize that speciation and extinction are natural processes on our planet. At some point, all species on our planet disappear. Some species go extinct not long after their origination, while others have survived on Earth for hundreds of millions of years. Scientists have identified over 1.4 million species on Earth, and some researchers estimate that there could be anywhere between 3 million and 30 million species of plants, animals, fungi, protists, and prokaryotes overall. Paleontologists, so far, have discovered more than 250,000 species in the fossil record. Many of these species are extinct. The number of species that have ever existed on Earth may be astronomical. The number of species is directly related to biodiversity. Biodiversity is the variety of life on the world, or alternatively, in a particular place or ecosystem. Counting taxa, like species, is one of the easiest ways to get a sense of biodiversity. This statement is particularly true in paleontology, as species are often easy to identify but hard to understand, since they are no longer alive today. For centuries, paleontologists have wondered how the biodiversity of our planet has changed over time. One of the first geologists to tackle this question was John Phillips, the Englishman who developed and published the first global geologic timescale. Phillips, of course, employed biostratigraphy to develop the geologic timescale. In the process, he studied the fossils that are unique to rocks of different ages. Using this knowledge, he produced the first Phanerozoic diversity curve. A Phanerozoic diversity curve shows how Earth's biodiversity has changed over the last 541 million years over the course of the Phanerozoic eon. Biodiversity is represented on one axis by the number of taxa, such as the number of species, genera, families, or orders. The other axis is geologic time, spanning from the past to the present, from the beginning of the Phanerozoic to now. Phillips' diversity curve was rudimentary at best. He basically guessed how many taxa existed at different times in Earth history, given his extensive knowledge working on biostratigraphy. That said, the curve was intriguing. It suggests that biodiversity has increased over time. Life has been becoming increasingly more diverse since the beginning of the Phanerozoic. In the century following Phillips' work, many paleontologists attempted to expand on his research. But their efforts were generally limited by the technology and resources at their disposal. In particular, they struggled to keep records of every taxon in the fossil record. Again, there are hundreds of thousands of species in the fossil record, which have been reported from all around the world. Prior to the advent of computing, it was virtually impossible for paleontologists to keep track of where every taxon came from. A breakthrough, however, came in the 1970s. In the late 1970s, a paleontologist named Jack Sepkoski revolutionized our understanding of biodiversity and provided some of the best evidence up until then for the existence of mass extinctions. As a graduate student at Harvard, Sepkoski conducted an extensive review of books and articles in the library and compiled a compendium of data on thousands and thousands of marine animal taxa, including orders, families, genera, and species. The compendium includes information on when each taxon appeared and disappeared in Earth history. In other words, it contains information on when each taxon originated and when it went extinct. To facilitate this work, Sepkoski compiled the data by punching holes in cards, which he fed into the computers available to him at the time. This work took years, over which time Sepkoski spent many long hours in the library. But in the end, the work paid off. Using his compendium, he produced a Phanerozoic diversity curve like this one. Again, biodiversity is represented by the number of taxa. The vertical axis shows the number of families of marine animals preserved in the fossil record. The horizontal axis illustrates geologic time spanning from the beginning of the Phanerozoic 541 million years ago to the present. Like the diversity curve that John Phillips had produced more than a century earlier, Sepkoski's curve showed that the number of taxa has increased over time. The biodiversity of the planet has grown over the past 541 million years. In addition, Sepkoski's work revealed two other interesting trends. First, he showed that there were three groups of marine animal taxa that rose to prominence and declined in unison. Each of these groups, which we call evolutionary faunas, dominated a specific time interval in terms of number of taxa. The Cambrian evolutionary fauna consisted of trilobites, inarticulate brachiopods, and worms that were very diverse in the Cambrian. In the Paleozoic, most taxa belonged to an evolutionary fauna consisting of articulate brachiopods, crinoids, cephalopods, and coral, among other things. Finally, the modern evolutionary fauna dominated the world in the Mesozoic and Cenozoic. It still dominates the world to this day, with most marine animals being snails, clams, crustaceans, fish, shark, and sponges. Most importantly, Sepkoski's work demonstrated that there were 5 times during the Phanerozoic eon when the number of taxa sharply and significantly dropped for a time. These drops represent rapid declines in biodiversity caused by the extinction of taxa. We now call these events the Big Five mass extinctions. These mass extinctions occurred at the ends of the Ordovician, Devonian, Permian, Triassic, and Cretaceous periods. There were other extinction events in the last 500 million years, extinction events of minor and intermediate scale. But the Big Five were by far the largest and the most severe extinctions. The Permian mass extinction was the biggest. Some estimates suggest that 96% of all species on Earth went extinct at that time, around 251 million years ago. The other mass extinctions, likewise, saw the disappearance of more than 70% of species. In other words, 3 out of every 4 species disappeared during the Big Five mass extinctions. Wow. Since the work of Sepkoski Paleontologists have dedicated significant effort to determining what causes these mass extinctions and to better understand why certain organisms went extinct during each event. We've learned that the mass extinctions were all different. Some were caused by glaciations. Others were probably caused by massive volcanic eruptions. Of course, some were caused by asteroid impacts. And there is good reason to think that one or more of the mass extinctions were caused by global warming or climate change. Overall, the fossil record tells us that catastrophes are a natural part of our planet, and that life has, on multiple occasions in Earth history, faced total obliteration. But, on the bright side of things, life has survived and recovered after every major mass extinction event thus far. So, there is always hope. That said, given what we know about mass extinctions, I personally think we should do everything in our power to avoid another one. With all this knowledge, do we really want to gamble with our existence?